transformations. We talked about last class in we did some explorations on congruence transformations. So let's just go ahead and get started. This first exploration that we're going to talk about is talking about reflections. And what we did in class was I gave you a piece of patty paper, and you were supposed to draw a diagonal across that patty paper, and then draw a quadrilateral and label it A, B, C, D. And we labeled our line that we drew, our diagonal line, L. So from here, we then folded our patty paper so that the quadrilateral was on the opposite side of our line, and then we traced over our patty paper. And so you would have gotten something like this. Now mine's not going to be perfect because I'm doing it freehand, and I'm using a computer program as opposed to you guys doing it by hand and on your patty paper. So you're going to be a little bit more accurate than me. And so yours should look similar to mine, but it's not going to be exactly the same because mine's not perfect. So then we labeled it A prime, D prime, C prime, and B prime here. All right. And so from here, I had you discuss what you notice about comparing the two objects. And you should notice that from the pre-image or the original object to the image, they're going to be congruent. In fact, they're the exact same thing. The next thing that I had you do was I had you draw a line segment from B to B prime and D to D prime, and I had you think about and discuss with your neighbor the relationship between those two lines and between line L. What you should have noticed is after we labeled our points of intersection here with N and M, you would have noticed that DN and D prime N are congruent, which means line L bisects that blue segment. It'll also bisect BM or B to B prime at point M. So M and N are the midpoints of those two line segments, those blue line segments. And so from here, you would know that L is the perpendicular bisector of a segment that connects the pre-image and the image. So whatever two points you connect that are the same similar point, the segment, it gets bisected by the line of reflection at a perpendicular angle. So these angles are right angles, and they bisect each other, or the line bisects the blue line. The next transformation that we did was translation. And I first had you start off by drawing two lines that were parallel on your patty paper, and I had you label them line 1 and line 2. Then I had you draw a triangle in the top left-hand corner and had you label it A, B, C. Then from here we did just what we did in the last one in the reflection section. I had you fold over line L and then trace your your pre-image, there we go, there's the word I was looking for, onto your patty paper. And now again, I am doing this by hand and with a computer program, so it's not going to be perfect, but you should get the same idea, and you should remember this from class. So we had you trace that, and you ended up with the image of our pre-image. And then I had you do the same thing over line 2, but this time I had you do it with the pre-image over line 2. So we folded over line 2, and we copied we copied over our pre-image, or our image from A prime, B prime, C prime. And what you would notice, I hope, so we get A prime, B prime, C prime, but this time, this is the second time we've done a transformation. It's the second image that we've done. So we use A double prime, B double prime, C double prime. And one thing that you should notice is that if I reflect our pre-image twice, and we reflect that over two parallel lines, this is the same as just moving or translating our original image, our pre-image, to the double image, our A prime double prime, B double prime, C double prime. One other piece of information that you guys would have learned from the exploration is if I it's not exact, but if I were to draw a line segment from A to A double prime, A prime would go through that. So would C prime with C and C double prime. And any other line segment I connect with any other type of object, if I connect the original, the pre-image, with my double prime image, the line segment would go through all the same points. So A prime, A double prime is all connected. And again, our lines bisect those portions. So if we look at the points from A to A prime, that's bisected by line 1. And from A prime to A double prime, that's bisected by line 2 at a 90-degree angle. So the same thing is present here. You'll also notice that the length of A to A double prime is the same as C to C double prime. So I can say that these two segments are congruent. That's one key feature. And so that's what a translation is you move all the points the same distance and the same direction. And we'll talk a little bit more about this, but the blue lines act like a vector. So if I were to draw an arrow here, the distance and the direction come from this vector. A vector is kind of like a ray. So from here, that's translation. From here, we talked about rotations. And a rotation, what I had you do is I had you on your patty paper draw two lines intersecting. And it didn't really matter where they intersected, but I think we tried to make it a perpendicular angle. So we said this was line 1 and this is line 2. And I had you draw, I believe, a triangle in the top left-hand corner again. Just for the sake of space, I'll draw a triangle here. If we did a parallelogram or a quadrilateral in class, that's no big deal. It works the same. So I had you reflect over line 1 first. So we get something similar to this. For the sake of room, I'm going to draw mine a little skewed. So we get the following image, and then I had you reflect again, only this time I had you reflect over line 2. So you get something that looks like this. And so we get C double prime, A double prime, B double prime. And the only difference from our original pre-image to our double image, our A prime, double prime, B double prime, C double prime, is if you were to take your patty paper and rotate it back, you would get the same image. And so this is what we call a rotation. Now we've rotated around this point, which we call the center of rotation. So that's basically rotation. We have a center of rotation, Again, the pre-image and the image, or even the double image, will be the same. One other piece of information is when I rotate at a positive angle measure, that's actually going to be counterclockwise. If I rotate at a negative angle measure, that's clockwise. It's counterintuitive, but part of the reason we do this is explained more in trigonometry. So those of you who are planning on going further in your math education will see this again later on. So that's pretty much what we did as our exploration. So let's take a look at some other key points of information. Okay, so these are all what we call congruence transformations. And all these congruence transformations have is from my pre-image to our image. They are going to be congruent. That's why they're called congruence transformations, because each object is the same. Even if I move it or change its location, it will be the same shape. Another name for these is isometry. And isometry, what that basically means, it has two parts to it. Iso and metry. Iso means the same or same, and metry means measure. So when we look at the pre-image to the image, we're doing isometry because we end up with the same measure. So if you think about iso, you can think about in terms of science. You probably have heard the word isotope at one point in your education in science. And isotopes are just two different versions of the same element. So you should have heard isotopes before. So it's the same element just with different variations of each other, but isometry is in terms of measuring the same object, and they have the same measure. So that's another word for congruence transformations. So when you hear the word congruence transformations, you can also think isometry. Again, our original image is called the pre-image, and our final result is our image. One other piece of information, when you label your original pre-image, we label it without any dashes. So if we have A, we start out with A, and our image is then A prime. So it's called A prime, kind of like Optimus. Okay? So if I then make another image of my first image, that would be A double prime, and then A triple prime, and so on until I'm done making images of the images. Okay, so one other piece of information that I might not have mentioned before is orientation of labeling, naming orientation. And naming orientation basically is talking about how I name my object. So if I have a triangle ABC, I have labeled it in the clockwise direction, how a clock turns. When you're talking about translations and rotations, they all have the pre-image and the image have the same labeling orientations. So if your pre-image is labeled clockwise, your image will also be labeled clockwise for translations and rotations. However, if you are reflecting for reflections, if your pre-image is labeled in a clockwise direction, when you translate or reflect rather, to your image, you go in a counterclockwise orientation. This is called reverse orientation. All this is telling me is I go in the opposite direction when I label my sides. Again, one other piece of information for reflections is the line that is between the image and the pre-image is bisected by the line of reflection. And that line of reflection is also at a 90-degree angle, or a right angle. So the line of reflection is the perpendicular bisector of the segment that goes between the pre-image and the image. The last few pieces of information before we move on to our example. With a translation, another way of saying this is a slide or a move. And another way of saying a rotation is we just turn the pre-image to get our image. And the last thing is vectors. This is probably the first time you might have heard the word vector unless you've taken physics or you are in physics. A vector determines the size or how far you travel and the magnitude. And that the magnitude tells me the direction. So left, right, up, down, diagonal at this direction. So size tells me how far or distance. And magnitude tells me the direction. So an example would be, well, let me just go on to the example section and we'll do an example of how to translate in using vectors. So let's say, oops, that's not a good coordinate plane. There we go. So let's say I have the following triangle. Okay, and I'll label it A, B, C. And they say to translate 6 units left and 5 units down. To do that, you would take every point's value, its x value, and you would shift it 6 units to the left. So if I'm talking in terms of vectors, I would move it 6 units to the left. First, I would do that first. Okay? And then I would then go 6 units or 5 units down from that same point. Okay, so my resulting A prime would be at this point. I go 6 units this way and 5 units this way. So my A prime would be at that point. I do the same thing with B and C. So when I translate, when I'm done translating this, my A prime, B prime, C prime would be at this location. 6 units left, 5 units down. Now 6 units left is the same as a negative 6 units. And 5 units down is the same as a negative 5 units. So if we say A was actually at 2, 3, or 2, 1, let's say, I'm going to do minus 6. So from A to A prime, I do 2, 1, and then I would subtract 6 units in the x, so I do 2 minus 6, and I would subtract 5 in the y, so I do 1 minus 5. So my A is at 2, 1, my A prime is at -4, -4. So that's a translation. And to find B and C, you would do the same process, just using the coordinates for B and C. So that's a translation. For a reflection, you would do the same process. We're going to do more practice with this next class, where we look at what happens when we reflect over a specific line or an axis. And we're going to do the same thing with rotations. What happens when I rotate my object 90 degrees, 80 degrees, or 180 degrees, 45 degrees. We're not really going to be concerned with anything but multiples of 90 degrees, just because we're not in trigonometry yet, and it gets a little bit more confusing when you get outside of 90 degrees. So that's your example for today. So let's move on to your multiple choice question. So here's your multiple choice question. If you have any questions on how to solve it, or any confused about anything else in this video, please comment on the video on YouTube, or at least, at the minimum, if you're watching this video for your grade, for your homework, fill out the form, question 5. Here is your free response question. Oop, looks like I got a Facebook notification. So, here's your free response question. Go ahead and pause the video at either your multiple choice or your free response, and have a great rest of your weekend.